Having your own customized items that meet your specific need in practicability and material comfort is great. But in general, such customization service is expensive and not accessible by average users. Is there a solution? Hi, my name is Chen Liu, and I'm happy to introduce our work, User-Centered Property Adjustment with Programmable Filament to you. Programmable filament is the novel technique that enables end users with low-cost FDM 3D printers to equip multi-material printing without any hardware updates. Specifically in this work, we applied this technique in conducting dual material filaments which are composed of the TPU and PLA materials. We carried out a tensile testing experiment to explore tensility of samples made of such filaments. We prepared uniform-sized dot bone samples with different settings such as raster angles, material compositions, and TPU to PLA ratios. A universal standing tensile testing machine is used to measure the corresponding stress of a given strand. At the end, we compared and analyzed the stress over strain relationship of all sample groups. This experiment demonstrates that the composition of TPU and PLA displays the median property of the two materials in terms of tensility. And this median grade property can be adjusted by varying ratios of materials. With this conclusion in mind, we used our programmable filaments to make two real-life applications that can expand their usage scenarios by changing physical properties. One is the flexible linkage, which is the hardware piece that is often used in connecting and alignments. The other one is the COVID-19 mask breather, which expands space between human face and mask. For these two applications, increasing the PLA ratio contributes to great support, and increasing TPU ratio achieves great softness. At the end of our work, we proposed some connection structure improvements to reinforce binding force among different materials.